Electricity. Matched terms and statements. Answer. Current. The flow of electrical charge and similar to the flow of water in a river. Measured in amperes. May be either alternating or direct. Power. The rate at which work is done or energy is produced. Power. Measured in ohms. Measured in watts. Resistance. The opposition offered by the wires of a circuit to the passage of electric current. Resistance. Measured in ohms. Voltage. The electrical potential or potential difference between 2 points. It indicates the strength of the push or pressure in an electrical current. Measured in volts. Voltage. What happens when wires or appliances carry more than their rated electrical capacity? Answer. When carrying more than the rated capacity, wires or appliances may overheat and cause fires. Complete the following. Current I times resistance R equals voltage V. What voltage produces a current of 500 amps with a resistance of 50 ohms? Answer. For this problem the formula we need to use is E equals I times R. We plug in the given values to determine the unknown value E. E equals I times R, current times resistance. E equals 500 times A times 50R equals E equals 25,000 volts. The required voltage is 25,000. What is the current produced with a 9-volt battery through a resistance of 100 ohms? Answer. For this problem, the correct formula is I current equals E/R. We insert the known values and solve for the unknown. I equals E over R. I equals 9 volt over 100 ohms. I equals 0.09 amps. The current produced is equal to 0.09 amps. What do fuses and circuit breakers do? Answer. Fuses and circuit breakers are designed to burn out or to break a circuit to prevent burning of wire conductors. Which electrical concepts discussed in the study guide have relevance to operators, and explain why? Suggested answer. All of the electrical concepts presented in the student guide are relevant to operators because these concepts may help operators to understand how electrical equipment works, as well as to help them understand how to do their jobs more safely. Hydraulics. Combined statements. Answer. Velocity. The average speed at which water moves through a certain cross-section or past a certain point can be measured in kilometers per hour or meter per second or miles per hour or feet per second. Pressure. When water flows through a system under force, measured in kilopascals or psi. Flow. The measurement of water or liquids that flow through a conduit or pipe during a certain time period, usually measured in liters per second, meter cubed per second, or megaliter per day. Describe the relevance of flow to operators. Flow is one of the most important measurements an operator uses. Flow provides information on the detention times in tanks, flow between various processes or sections of a distribution collection system, chemical feed rates, amount of water treated pumped, costs of treatment, and the need for system expansion. Describe how an operator might measure flow. The types of measurement are dependent on whether the water is flowing in a closed pipe or in an open channel. Open channels are measured using weirs or flumes. A weir is a dam or obstruction in the channel. A flume is a specially shaped constriction in the channel. In both cases, the flow is related to the height of water at a particular point. Some of the common methods of measuring flow in closed pipes include Venturi meters, ultrasonic meters, magnetic meters, Doppler meters, and orifice meters. Describe the difference between static pressure and dynamic pressure. Answer: static pressure refers to the force exerted when water is at rest and not flowing. Pressure exerted by flowing water is known as dynamic pressure. Define pressure head. Answer: the pressure at the bottom of a water column depends directly and only on the height of the column. When pressure is expressed in this way, it is commonly referred to as head. The head is expressed in meters of water. In which situation would the loss of head be greater? Water flowing through a new pipe with a smooth interior surface, or water flowing through an older pipe which is rusted on the inside? Answer: head loss is the pressure loss due to friction as water flows through a pipe, tank, filter, etc. For example, water flowing through a pipe loses head as a result of the roughness of the pipe walls or restrictions within the pipe, changes in diameter, valves, etc. Generally, the larger the pipe diameter and the smoother the interior pipe surface, the lower the head loss due to friction will be. Therefore, head loss would be greater in the old, rough pipe. Define water hammer, how it occurs, and how it can be avoided. Answer: water hammer occurs when a moving fluid suddenly stops. The energy which must be absorbed within the system can create pressures which can destroy piping and appurtenances. That's a big word. To avoid water hammer, valves must be operated slowly and pumps started and stopped gradually. Operators should be aware of situations where water hammer could have costly or disastrous effects. Define cavitation, how it occurs, and how it can be avoided. Answer: cavitation is the formation and collapse of a bubble or gas pocket. Cavitation can occur as a result of very low pressure within a pump. This low pressure causes the water to boil, releasing tiny bubbles. The bubbles then collapse with enough force to damage the pump impeller. When operating pumps, it is important to follow the pump directions. Cavitation can be avoided if the pump capacity, speed, head, and suction lift are properly determined. Which hydraulic concepts have direct relevance to water operators, and describe how, why? Answer: all of the hydraulic concepts presented in this chapter are relevant to operators because they are all related to the safe and efficient operation of the water system. What is the flow rate in feet cubed per second of water flowing in a rectangular channel that is 12 inches wide with a depth of 8 inches at a velocity of 3 feet per second? Answer: flow rate equals 2.0 feet cubed per second. Water flows through a triangular channel at a velocity of 8 meters per second. The depth of the water in the channel is 60 centimeters and its width is 45 centimeters. What is the flow of water out of this channel? Answer: flow rate equals 129,600 liters per minute. The flow in a cylindrical pipe that has a diameter of 0.9 meters is 3 meter cube per minute. What is the velocity of the water in meter per second? Answer: velocity equals 0.078 meters per second. Equipment basics. Describe the types of equipment that operators may be required to operate. Answer: operators may be required to operate pumps and valves as well as various controls and instrumentation systems. Should a failure of any of the equipment listed in the question above directly or indirectly result in a serious problem? If yes, provide some examples. Yes, failure of any of the above pieces of equipment may result in serious operational problems. Describe the key differences between centrifugal pumps and positive displacement pumps. Answer: the centrifugal pump pressurizes water by throwing it at high speeds from the center of the impeller to the outside. Positive displacement pumps operate by pushing the fluid mechanically. What is the purpose of a packaging gland, and describe possible signs of wear? Answer: packing glands are seals which prevent the pumped fluid from leaking from a pump. The seal also prevents air from entering the pump casing. Packing failure can lead to expensive repairs if not noticed in time. Signs of wear include poor pump performance, flooding, and rusted or damaged components. List the types of materials often used in pipes. Answer: water and wastewater transportation systems can use cast iron pipe, ductile iron pipe, steel and reinforced concrete pipe, asbestos cement, and plastic pipes, PVC, PE, ABS. Describe the purpose of valves. Answer: valves are used to stop or control the flow and pressure of a liquid or gas in a pipe. List some different types of valves, and for 3 of these valves, describe their purpose. Answer: many different types of valves are used in wastewater systems. These include gate valves, globe valves, butterfly valves, check valves, eccentric valves, air and vacuum relief valves. Gate valves are used to completely stop the flow of liquid or gas. Globe valves and butterfly valves can be used to control the amount of flow or pressure through the pipe. Check valves are used to ensure that the liquid or gas can only travel in one direction in the pipe. Air and vacuum relief valves are used to release or admit air into a piping system. List some key variables that might be monitored by measuring or metering devices typically used in wastewater treatment. Answer: wastewater facilities have a wide assortment of measuring or metering devices, including flow measurement, temperature, and pressure. Describe the principle of a feedback loop and relate this to control one of the variable mentioned in the above question. Answer: in a feedback loop system, a flow measuring device measures the flow of water within a pipe and sends an electronic signal to the controller. The controller compares this flow with the desired flow. If the flow is outside the acceptable range, the controller sends an electronic signal to a valve. The valve either opens or closes in order for the desired flow to be achieved.